Hey everybody, it is time once again to take equations and turn them into pictures. It's time for Graphs with Mr. Troy. Sorry for blowing out the microphone there. I bet that was pretty annoying. Alright folks, the focus of today's video is to learn how to graph two other forms of quadratic equations. One of them you have done before, but that's okay, we'll go over it again. And one of them is most likely new to you. So the first is when you are given an equation in standard form. Think something like this. We start by labeling each term. So in this case, A would be 2, the lead coefficient, B would be -3, and C would be -5. This A is going to do the same thing no matter what form you're graphing in. So if you're someone who wants to use the 1, 3, 5, 7 rule, that A is going to function in exactly the same way. Now, what C tells us is the Y-intercept. And the reason that C tells us the Y-intercept is it says if we plug in 0, then what do we get for our equation? Well, the A term and the B term are going to cancel out because they'll have a 0 in them, but the C term will be there. That's why it's called the constant term, because the X does not affect it. The other part is the axis of symmetry, and I bet you know where the axis of symmetry comes from if you think about it. X equals opposite B plus or minus the square root of b squared minus 4ac all over 2a. So this comes from the quadratic formula. If the zeros are this, then the plus would normally be the 0 to the right. It depends on what A is. And the minus would normally be the 0 to the left. So halfway between them would be the axis of symmetry. So in this case here, it would be the opposite of B over 2A, or the vertical line x equals 3/4. Okay, so we're going to do one of these problems, and you cannot divide by -2 in this case. You would still get the same zeros, the same x-intercepts, the same solutions, but you would get a different graph because you'd be changing the steepness. So you can't just get rid of that -2. So we start by placing the y-intercept, which is -6. And after we do this problem, I'll give you a big hint on something that we can do to help us better visualize the graph. The next thing we're going to do is we're going to find the axis of symmetry. So we're going to say x equals the opposite of b over 2a. And we're going to place that on our graph. Now, because that's an axis of symmetry, there would have to be another point right here to make these 2 points symmetrical. I know you're looking at this and you're like, okay, what more detail can you give me? Well, since this opens downwards, the graph is going to look like a frown. If you want to, you can use the 1, 3, 5, 7 rule from here, and you can try and intuit your way backwards to where the vertex would be, or you can take that x-intercept and plug it into the equation. Sorry, the x-coordinate of the vertex, not the x-intercept. It might be the x-intercept, but not necessarily. So you're going to take the x-coordinate of the vertex, that x-axis of symmetry, and you're going to plug it into the equation. And this will look like that. So I plug this in, And I evaluate it using the order of operations, and I get 2, 2. Now, say you wanted to use the 1, 3, 5, 7 rule instead. That would be okay. The changes would be a step of -2, then a step of -6, then a step of -10. Let's check out what that looks like. Take a step over, down 2. Take a step over, down 6. Oh, that matches with what we see. So if you want to, you can reverse engineer that using these 2 steps. So it all comes together pretty quickly. Remember, if you don't want to use the 1, 3, 5, 7 rule, you always have the option of making a table. As we say, when in doubt, t-chart it out. So if you don't like the 1, 3, 5, 7 rule, then just like we did here for the y-coordinate of the vertex, you could plug in all of these different x values, the old-fashioned way. A quick thought here. If something is missing a b term, you can think of it as being in vertex form. The vertex would be 0, -9. And then the graph would use the 1, 3, 5, 7 rule, 3, 9, 15, 21, and it would work the same way. So anything that's missing a b term can also be thought of as being in standard form or vertex form, whichever one I didn't say. It could count as... One last note about standard form. Your textbook refers to standard form as general form and vertex form as standard form. Just a thing to know. Just a difference in opinion between most high school math teachers and the fine fellow who wrote your textbook. Okay, the next form is called Intercept form, and it's going to look factored. So here is an example of Intercept form. Here, the A is still going to describe your vertical stretch or shrink. So this graph would still have a 1, 3, 5, 7 rule that would use 3, 9, 15, and 21. And these 2 values help us find the zeros. So the x plus 1 is going to tell me that -1 is a 0. And the x minus 1 is going to tell me that +1 is a 0. Now, either of these x's could have a coefficient, so we could have an equation that looks like this. But we're going to be less likely to use the 1, 3, 5, 7 rule in that case, and we might try a different option for graphing. All right, so here's an example, and here's how we'll approach it. So what we're going to do is we're going to start by plotting the intercepts, and those are going to be at 3 and 5. Now, the axis of symmetry has to go directly between there. So we're going to drop our axis of symmetry exactly halfway through, and you know from your geometry class that the midpoint formula just asks you to add those 2 things together and then divide by 2. So 3 plus 5 divided by 2 is x equals 4, which means our vertex is going to be 4, comma, something. Now, if you understand the 1, 3, 5, 7 rule, you know that we're 1 step away from the vertex, and the first step off the vertex is down 2. So you might be able to intuit how to do it from there. But it's okay if you don't, because you can plug it into the equation. You can plug 4 into the equation. Let's see what that looks like. So when I plug 4 into the equation, I get 2. From here, you can use the 1, 3, 5, 7 rule if you like, or you can continue to just plug in what happens if I plug in 6, what happens if I plug in 7. So in order to show that I'm not always doing the same thing, let's take a look at that method. Okay, so this is how I would set up if I wanted to plug in x equals 6. Say I don't love the 1, 3, 5, 7 rule. Now, I would never say that because I love the 1, 3, 5, 7 rule. I adore it. But if you don't like it, that's okay. So you'd go ahead and plug it in, and you'd say y equals -2 times, let's see, that's 3 times 1, which I think is -6. And then you would plot 1, 2, 3, 4, 5, -6, and then go plot its mirror point on the other side. Again, many ways to do these things, and it's okay if you don't use my way. So I filled in some of the information there, and I did my best to make a graph. The last piece of information that we need is the Y-intercept. So remember, the way you find the Y-intercept is by setting x equal to 0 and then solving. I think when I do that, I get a y value of -30. So my y-intercept is 0, -30. All right, there's one last piece of information that I want to share. That's a treat for those who stuck around to the end of the video. So we're going to go back to standard form. Okay, I said that there was something special about the b term in standard form. And that thing is that it tells you the slope of the tangent line of the graph as it goes through its y-intercept. Now, the reason for this is calculus, so you don't need to know the reason yet, but basically, as the graph passes through the y-intercept for that instant, it has an instantaneous slope of 8/1. Now, here's how this actually helps you. Knowing that doesn't really do anything for you, but what it helps you with is the following. If you have a positive b, that means your graph is increasing as it goes through its y-intercept. If you have a negative b, that means the graph is decreasing as it goes through its y-intercept. It can really help you picture what a graph looks like without having to figure out as much about it. Should I go full YouTuber? All right, everybody, thanks for watching the video. Make sure that you like and smash the like button and like the video, and make sure that you ring the bell for subscribe. I don't know how to go full YouTuber, but make sure you smash that like button, okay? All right, everybody, have a good... Can't even take myself seriously. Have a good one, everybody. I'll see you later.